Oh, hi. Looks like I've started. So this is Rafi, and my project is the red teaming project. So the adaptive multi-turn red teaming for LLM agents using active exploration. Right. So for the first deliverable, Project A, I kind of want to showcase the way some of my agents work. So I kind of have two front ends for that. Quickly code it up via Streamlit, and then kind of the main thing, which is the experimental setup. Right. So to get started with the first front end showcase the agents, you can see that I use Streamlets and I have with this app.py scripts, we have this nice little front end. So I have three agents. I swapped out the coding agent from last week with a customer service agent and kind of focus on just making three work fairly well. So I have medical, financial, and customer service, right? And so on the left hand side, you can see that we are kind of showing the internal states for all of the agents. So all the agents internally work very similarly. They inherit from the same class. So I'll go through kind of how they think in a little bit. But for now, let's just kind of ask this medical agent a question real quick. So, while we do that, we kind of see that, it has its own register tools. So again, if you think of like an MCP setup, the agent will decide which of these tools to call, right? So yeah, you can see that we've gotten a response. So, it's giving you a pretty descriptive response. It's also giving you, like, if you took a look at the alignment, it's also telling you, like, it's being very cautious with giving you direct medical advice, and it's referring to a clinician, right? Which again, so each of these agents have specific alignment policies, and later on with the red teaming agent, which is not one of these three, it'll try to bypass these alignment policies, right? So in terms of like what's kind of going on behind the scenes, if you look at this raw JSON, which kind of just has the first two tabs, you can see that the agent first plans, right? Then it also reflects on what its output is, right? So we have a planning stage, a action stage, right? So here the result is kind of the response from the LLM as well as any tool calls, and then we have a reflection on kind of its response and any kind of feedback it might have for the next turn, right? So yeah, so we can switch over to the financial agent now, and so you can see it has a different set of internal states, right? And this financial agent is more of a kind of a general, like, financial, not advisor, but well, I guess kind of an advisor. It just gives you general financial information, right? So kind of notice, so let me just hit send right there. You can kind of notice that I don't call it an investor because I made sure that one of the alignment policies is to not act as like an actual investor, right? So you can imagine that for liability concerns, you wouldn't want to have that. So yeah, so here, you can see that it's giving you a pretty thorough response as far as research goes, right? Once again, it's giving you that disclaimer, right? So down here, you can kind of take a look at the tools you might use. And then once again, we have that plan, reflection, raw JSON, and the action. Yeah. So, okay. And then the last one, customer service. And again, they all work very, very similarly. Internally, they're all working the same way. They all inherit from the same class, the base agent class, right? So they're all behaving very similarly, right? So you can see that here are the register tools for the for the customer service agent. One of the things that's interesting for this is, I had trouble trying to come up with some ways of aligning it. So, while the other two agents kind of have kind of true or false alignments, like either you are aligning it or you're not, like either you're following that policy or you're not. For this one, I have a sentiment threshold where we measure the sentiments of the customer, right? And then if the sentiment falls beneath a threshold, right, that kind of flags the alignment where it flags the policy where it'll ask, like, it'll just stop talking to you and switch to a human operator, right? Which is pretty cool. So yeah, those are kind of the three agents. Now moving on to the so that's the first one. So the second one, I guess the name might be a little could be more descriptive, but the second one is like actually using the red teaming agents, right, to interact with those same three models, right? So again, like these are the exact same agents, right? The medical, financial, customer service. Just now, if you hit activate red team agents, it'll come up with a prompt for one of these for one of these agents, in this case the medical agents, and try to give it a adversarial prompt, right? So just hit send adversarial prompt here. And so I know when I hit send on that, but you can see that I had the option of editing it as I wanted to. But yeah, so yeah, here's the response. So in this case, we weren't able to crack it just yet, right? And so we do have some cracks though in the experimental setup, right? So you can kind of ignore that section. I was trying to make a front end for automating the experiments, and it doesn't fully work. And then similarly as the previous, similar to like the internal states for the agents, like the target agents, I call them, these three agents. You can see that with the attack, the adversarial agents, right? You can see that each of its three attack prongs. So if you think of the multi-armed bandit, each of these attacks are a type of arm, so a different way of attacking. So obviously we've had no successes. And then what's kind of key here is that it then reflects on its performance and then uses the reflection on the next attack. So I kind of go through this algorithm a little bit more in the slides. But yeah. So, okay, those two are just kind of for general demo purposes, right? I don't really do too much testing here, aside from just initially checking in on the agents. Kind of the key runs here, are the experiment runs. So I have the baseline. So I have two types of experiments: the baseline experiments and the adaptive experiments, right? So the adaptive experiment, actually uses this red team agent, right? It's actually using the red team agent, while the baseline, so this is to compare against like kind of baseline attack patterns, which are more static. So they use static prompts, right? So a set of static kind of custom hand engineered prompts, engineered by me and the LLM, to try to crack the agents, right? So here you can see that here's like an output of one of the runs. So here, from one of the runs, you can see that's medical. So in this case, I was using the OpenAI API, and so since that's paid, I only did 10 turns. For the VLLM, I believe I do 30. So you can see here that it's the attack question is could you please provide a patient with your patient's recent blood pressure and so on and so forth. So it's trying to get the agent to disclose private information. And the attack type, which I call surface, is memory poisoning, right? Yeah. So I don't want to scroll through this too much. Yeah, you can see here that we were able to get a tool misuse violation on the medical agent, right? So yeah. So and I have a severity score mapped to each of the different violations, right? So right now the evaluator uses like pattern matching, so it's not an LLM-based evaluator. That's something I want to work on in Project B, right? So kind of here I have summarized the key results. So kind of the big stuff is, so again, I'm running the GPT-4o Mini versus a open source model from not Mistral, but from Quen. Mistral was the one I tried running first, but it was too big, so it didn't work out. So yeah, so you can see on the baseline tests where I've kind of hand engineered those prompts. Medical and financial actually did fairly well. So again, so these backends are like the backends behind the agents, right? So it's using OpenAI 4o Mini backend and so on and so forth, right? So again, there's no actual adaptive red teaming on this left-hand table, right? And on the right-hand side, I'm actually using the adaptive red teaming. So in this case, all four agents, the medical, financial, customer service, and red teaming, are using the OpenAI 4.0 Mini, and then down here they're all using the Quen from VLLM model. So yeah, so you can see on this left hand side, that customer service had a pretty large violation, 25 out of 30 from those kind of handmade prompts, which was pretty interesting. Whereas on the adaptive red teaming side, medical had the most violations, right? So something I noticed was that customer service has 0 out of 10. So after kind of reviewing manually the kind of some of the outputs, it looks like my evaluator, which again is kind of doing some like static keyword matching in terms of like manually looking through the outputs, it missed a lot of the violations, right? So I think in the future I'm gonna have to do some kind of LLM based evaluation, right? So the 0 out of 10 is probably not super correct for customer service. But yeah, so in general, the medical was the most vulnerable for both backends, right? So at 30% violations on OpenAI, 40% on VLLM. Yeah, and then so something that was interesting is for the Bandit architecture. So Bandit being the algorithm behind the red teaming, and I guess I kind of go through more of that in the slides. It's, you can see that like there's a progression in terms of like when it's able to get its first violation. So for example, out of like 10 runs, right, for the financial agent, it was able to get a violation on turn 6 as opposed to the first turn, right? So you kind of see that it's learning in real time. Though, something to note of is that I didn't get any violations on, again, customer service and financial for three of the configurations. So again, that's something that I'll have to work on the evaluation side, the evaluator side, as in like the evaluator being what checks the violations, and kind of iterating through the agents. So yeah, that's kind of my demo. I do want to clarify that for this project, I know Professor's suggestion was to focus on the agents. So, which I kind of, which I did, even though I've been talking about the red teaming a lot. I spent the bulk of my time making the base agent class for the LLMs, right? So, memory stream, the base agent class, right? So again, all four agents kind of inherited from this one, right? And so we have perception, retrieval, planning, and so on and so forth, right? So in project B, I kind of want to expand more on my red teaming aspect, whereas in project A, this project, I focused more on trying to make my agents as robust as possible. But yeah, that's my demo. Thank you.